All right, hi everybody. Thank you so much for joining. So this is the Positive Physics Chem STEM creator demo. While some people are still joining, and Abby, do you mind letting people in? If you have a kind of specific type of question that you were hoping to create, please go ahead and put that in the chat. And by the way, in about an hour, I'm going to do another demo that are just the basics of how to use positive physics, chemistry, and other courses with your students. But this one is specifically about creating your own courses, creating your own questions, creating your own simulation, and putting that into your own courses. So again, we'll get started in just a second, giving some people some time to get in. But yeah, if you don't mind adding to the chat, I'm just curious if anybody has ideas of specific types of questions that they're hoping to be able to create after this demo. All right. Cool. Great. So yeah, let's go ahead and get started. Let me pull up positive physics. And oh yeah, if you have questions at any time, you don't need to wait to the end. Go ahead and put them in the chat. Abby's going to be monitoring that. She'll interrupt me and let me know if anybody has any questions. So first, just really quick, there are some people here that are brand new to positive physics. Positive physics is a huge lesson and question bank that gives students interactive feedback and has randomized values. So again, this is more the demo later today that I'll show you all the basics of using this. But just for people who are brand new to the site, um, as students practice, they get instant feedback. All these values that are in blue are randomized, and I'm going to show you how to make questions like this and others. And again, students check their answers anytime. If they get something wrong, a little red X appears and they can fix it. What we've started spending a lot of our time, especially Abby, doing recently is adding a new type of problems, simulation problems. So if you're familiar with the site, you'll know that we start every unit with an inquiry activity. Usually those inquiries link to a PhET or we just presented data, but now we're making questions where there's actually students can interact with the problem and things move on the page and students can see data up here. So this was one we were just finishing up earlier today. This will be in the new physics unit 2 very soon. All right. Cool. So yeah, let me go ahead and show you how to create questions first, and then I'll show you how to organize those into a course. So first, I'm going to show you a really simple question. And by the way, this is to create questions, you'll go to the Advanced tab and you'll click on Create Questions and Lessons right here. So I went ahead and I typed out a question. It says, a bicyclist speeds up from rest to 12 meters per second. How far does she travel during this time? All right. So right now, this is hard-coded with those numbers in there. And so the first thing I'm going to show you is just how to quickly change this into a variable so that every student would have different numbers in their problems. So all I have to do
You
is,
should open up the directions page.
oh, yeah, thank you, Abby. Um, Before I do that, yeah, quick note, we'll send out the recording of this later, but also we spend a lot of time creating this directions page that has a whole bunch of notes, shows you what all of the buttons do. At the bottom, it talks about how to create a simulation. And then one other thing that's very useful is we also made these editable examples. So if you want to see a pre-made problem that you can then play around with, you can just click on one of those buttons and it'll come up and you can play around with it. I'm going to actually show you how to make kind of that exact question. There's lots of things that the site is capable of doing, like conditional answers or randomizing a word. Abby uses that a lot in chemistry when she creates questions that have like a certain element in it. You can add graphs, all sorts of things. So yeah, before I show you anything, first place to look is the directions and these editable examples. Those will take you a really long way. But yeah, let me go ahead and show you how to create just a simple question with a randomized variable. So a bicyclist speeds up from rest to 12 meters per second. Instead of that 12 meters per second, let's make that a variable. So I'm going to click on this button that says var. And then I'm going to call that velocity, let's call it v final. And then in the extra math, I'm going to define v final. And if you looked in the directions, you'd see that the way that we put in a randomized value is we use this function rand, and then we put in three values. So the minimum value, the maximum value, and then the number of sig figs that you want. So let's go ahead and say that v final is a random number. Let's say the bike can speed up anywhere from 6 to 10 meters per second, and let's keep 3 sig figs. All right, once I do that in the preview, you'll see that this number appeared. And so then this number is going to be different for any student that's doing their problem. And then it says, how far does she travel during this time? I'm going to put in an answer. Oh, I need to put in a time as well. During a t-second time interval. So let me go ahead and define the variable t as well. So I'm going to say t is a random number from 3 to 5 with 3 sig figs. So now we see that showing up. By the way, especially for chemistry teachers who might be able to pick about sig figs, you can change the values right here. So this one randomly came out to 3.60. I'm going to change it to 3 sig figs. So now no matter what, even if it comes out to randomly picks 4.00, it'll always show 3 significant figures. That's a relatively new feature that we've added right there. And then it says, how far does she travel during this time? So now I have my answer box, and I can put in my formula. I couldn't put it in right here, or I could type it in below, your choice. So I'm going to say that's going to be v final over 2 times t. Or I could just call that a variable d, and then in here I could say v final over 2 times t. Let's go over and click show answers, and we see that answer comes up. On Positive Physics, I always like to put units. I do that with the multiple choice option right here. And for the multiple choice tag, you put in, and again, check in the directions, and it'll show you how to do a multiple choice tag. And it's actually going to be very similar to this one right here. So the formatting is you put in the correct answer. So the correct answer here is meters. Then you put a colon, and then you put all of the answer choices with commas in between. So I'm going to say meters per second, or seconds in this case. That creates this drop down for me. Also, if you want to, this is optional. If you start with an asterisk, then that'll give it a default value. So if I want this to say unit, so students know that it's a unit, I can put it in right there. And now clicking show answer, my problem is done. And again, randomized values right here.
I just noticed, I think there might be a mistake in the distance equation.
Oh, yeah. V final over 2 times t. My bad. Thank you for catching that, Abby. There we go. Cool. And then one more thing I wanted to show you on this is we really like to add images. So, and we create all of our images in PowerPoint. So here's an image that I made with some stick drawings on PowerPoint. To upload this, I'm just going to save it on my computer. I'll call it bike race. We recommend using a PNG. And I'm saving it to my desktop right now. All right, so once that has been saved, I usually put in a section break and then click on image video, upload a new image. And I'm going to choose on desktop, we have bike race. You also give your image a name, just so if you wanted to use it later, you don't have to upload it again. You can just type in this same thing right here. So now we have this beautiful image next to our question over there. All right. So this is the simplest kind of questions, just inserting random numbers and having an answer that's a formula. But yeah, let me pause right there and see if anybody has any questions. All right. Real quick before we move on, I did see a couple earlier in the chat that I missed. It says, do students have the capability for students to draw diagrams from a description of an object's motion? We have the ability to, like, you could match with a diagram. So generally all of our answers are numerical, multiple choice, or we recently added symbolic answers, so you can have students answer with a formula. I'm not 100% sure, like, if you clarify exactly what you're asking. We don't have the ability for students to draw on the screen and then grade that. Like, part of what we want to do is make sure that everything you do here can be graded automatically. I also saw a question about ranking. Maybe at the end, Abby, can I get you thinking on how we would do a ranking question? But yeah, it's definitely possible. You can do a ton with this in, like, much more than just adding the numerical, like, randomized numerical values. But this is kind of like the easiest thing to get started with. Cool. Yeah. Any other questions on kind of creating basic questions? All right. So let me show you how you would actually put this question into into your own course. So right now I named it demo simple, and let me make sure I've saved that. So under the advanced feature, it also says create courses, units, and skills. And I can go ahead and create a course name. So actually, I already created one. I'll create another. So let's call it Jack's Course 2. So I go ahead and click on that, and it adds a second course. Now when I'm on my dashboard, I can see that there's all the courses that we have offered, plus any custom courses that you create. Right now it says there's no units available. So now let's add a unit. Let's say our first unit is motion, and it's unit number 1. And now I've added it there. And then I can add a skill. Let's just call it calculations. We're putting it in Jack's Course 2. And let me refresh the page here. Jack's Course 2. And our unit, my bad. Well, I'll just put it in this other one. So putting it in the test unit, I could make a skill called calculations. And then if I go to, finally, I have to place the question in the course itself. So I'm going to go to insert questions. And it's selected Jack's Course, test unit, test skill 1. I guess calculations is where I want to put it. And to add a question, then I know this one was called demo, and it was called demo simple. And now I've added my question to my course. So now my students could access that. You'll notice you can also click on existing questions, and this is where you can pull in questions from our course if you have a subscription. If you want to just use it with your own, with all of your own questions, that's completely free to do, but you would need a subscription if you want to use the stuff that we create. Yeah, so that's kind of the logistical stuff. If you want to see more of the logistical stuff, Abby, do you mind putting in the chat the link to the demo that'll start in 45 minutes? That's going to show you kind of just the basics of how do you add your students, how do you create assignments, things like that. All right. So yeah, any other questions just about creating simple questions or creating your own course before I dive into kind of part 2 of this webinar, is how to create your own PhET style simulations. And yeah, before I dive into that, let me see if there are any questions. Cool. And thanks, Abby, for putting in the chat the link to the next one as well. Okay, great. Cool. Okay, so this next one is for creating, again, PhET style simulations. And so this one, those first questions are super simple to make. This one, there's a little bit more of a learning curve, but stick with me. You can create some really, really powerful, really cool stuff. Allow students to take data from simulations on the screen and things like that. Again, my first recommendation is look at the question creator. I spent a lot of time making this. Look at the directions. I spent a lot of time making this part. The part about simulations is at the bottom, and it shows you kind of how to. There's a lot of how-to stuff. Also, some things that you can just copy and paste in, like background images, uh, pictures of bikes or cars or balloons, things like that, just to get you started playing around. All right, so let me go here. I'm going to start right here. And the first thing that I want to do when we create a simulation is when you create a simulation, the variable t becomes like a special variable. So it's going to run from 0 to, you have to tell it when to stop. So the formatting for this is just, and again, this was in the directions, is the first thing you want to do is you want to define, like, when do you want your time to stop? And let's say we want our simulation to take 10 seconds. I'm going to put in a variable right here. I'll say time equals, and put in a variable t. And we see that now I have this time that's running, and it runs to 10 seconds. You can also add simulation buttons right here, so it doesn't just loop automatically. Now you can play, you can pause, you can step forward, step back, or reset. I like to set the rounding to 1 decimal place, so it looks a little smoother when that time is running. And let me actually go ahead, and I also really like to organize it into a table. So let's start with time. And again, so this one's a little weird to start with because that variable t, you don't see it defined anywhere. But when we type in time.final, our code behind the scenes says, okay, that's telling us that you want a time that starts at 0 and runs to 10. All right, so let's say you just wanted, we're going to add an image later, but first let's just say, okay, I also want students to, I'm going to just make a really simple constant speed simulation. So I'm going to say distance, and then I'm going to put in a variable here. I'll just call it x, and I'm going to say that x is 5 times t. So now when I run my simulation, then I see this value for the distance. So this is just like showing the time and the distance if something had a constant speed. You don't have to have an image that kind of relates to this, but you could if you wanted to. All right, so then the next thing is, actually, let me pause real quick and see if there are any questions so far on just kind of, this is setting up the variables in order to make your simulation. And by the way, we have a relatively small group, so feel free to unmute yourself and just ask a question if you've got one. All right, so I'll go ahead now, and I'm going to I want to add an image, and I want to have something that's moving on top of the image. All right, so I'm going to first put in, I usually put in a section break before I put in an image. I could upload my own, or if I go over to the directions, there's some pre-made images that you can just copy and paste over. So this one says background image. It's a picture of the ground. I'm going to paste that in. And, oh, come on. All right. My bad, that's not working. But yeah, let me just upload a new image, and then or I'll use my existing image, and then I can just swap it out. So my bike, oh, I have one. It's already ground. So the other thing I could have done is I could have just typed in 1/pp So that one right there, if I wanted the pre-made ground image, if you didn't want to create your own. Okay, so here's my ground, my image of the ground. All right, so then the next thing we do is we want to be able to put something on top of it, and we call it an overlay. So any object that's going to be moving or rotating or anything like that, we're going to put on top of it. Yeah, we're going to use this thing called an overlay. Again, the directions are over here. So, and there's some that you can copy and paste in. So let's say I want to put in that bicycle. So I'm going to say overlay one dot image equals bicycle, and I'm going to paste it there, and that puts a bike on top of my image. Again, you could upload your own image if you wanted to. When I make these, what I do is I go into here, I just select the thing I want, and I say, where's the, save as picture. And this is just a bike as a PNG. When you do that save as picture, it makes the background a bit transparent, so it looks really nice when you put it on top of other things. But since I'm already using a pre-existing one, I'll just leave it as is. All right, so then I want to go ahead and I want to position this thing better. If I said, okay, let's say overlay one, and again, there's the directions for exactly how to do it for all the things you can define are in those directions page. I want to put the position. If I put it at 0, 0, and include that equal sign, then it puts it in the lower left-hand corner. 100, 100 would put it in the upper right-hand corner. Which is fine. You can define things by the percentages, but I'm going to show you a trick to make this a little bit easier. So let me get rid of this again, or I'll just put it back to 50-50. If I want to like have my grid represent meters instead of percents, I can add some things. I'm going to say image dot x min equals 0. So that means the left side of the image is defined as 0, and usually the right side of the image is defined as 100, like 100%. But let's say I'm doing my problem and I only want my problem to go to 40 meters. Then I can define it as 40. So on the right-hand side, when the bike gets to 40,
there we go.
X max. Then when the bike gets to 40, that means it's going to be right at the edge, the right edge. All right, so now it's just kind of a little bit of guesswork to figure out where exactly to place my image and also to size it. So if I say overlay.1.size, right now my bike's way too big. Let's try making it smaller, and then moving it over to the left-hand side, maybe like 4, and lowering the bike down. So there we go. A little bit of guess and check puts me at the right spot. But then I realized, like, okay, I don't want my bike always to stay in this position. I want my bike to move to the right. So I'm going to add, I could add this value x, how far it's moved to the right. And so now my position is going to be constantly updating as x, which is 5 times t, updates. So now I'm going to say play, and my bike is moving to the right. I could pause it, reset it. Like you could use this to give your students a question where they have to figure out how fast the bike is moving by pausing it at various times. Okay, cool. We got an from the comments. I love it. Cool. So one other thing, it's like, oh, well, right now every student's bike is moving at 5 meters per second. So instead of having it work that way, let's define a variable v. So say v is a random number between 5 and 9. Let's just go 1 sig fig. And then instead of x being the distance being 5 times t, I can make it v times t. And now when I click on play, okay, that one, let me reset it. So play and pause. I'm going to back up to 1 second. So that time it traveled 6 meters in the first second. Oh, I should add my units here like a good teacher. So that first time it was traveling 6 meters per second. 6 meters per second again, but if I reset the problem, now that time it was traveling 7 meters per second. So now we've made a problem with a randomized speed of the bike. So if you're asking students how fast is this bicyclist moving, let me actually just add that here. Then we could put in an answer choice that was V. And so different students would get different values. And they'd have to figure it out based on this. Okay, cool. And then one other option. So if we didn't want, let's say we wanted students to experiment with different things. We could actually let them try different velocities. So if I put in the sim options, what this does is this creates a drop down for me. Sometimes when you click on a button, if it's a little bit complex, I put in like kind of an example right here. So now I'm going to say, okay, V could be, let's go 4, 6, or 8. And now the student is selecting different velocities. And I should either add meters per second right here, or I can show you a slightly different way to do that in just a second. So now the student can play, and now the bike's moving 4 meters per second. Or they can,
Got to remove the it's defined in the extra math as well.
oh, it's defined in the extra math. Good call. Yeah, let me not define it there. So yeah, if I play this and I pause it after a second, I see it was moving 4 meters per second, or I can move that up to 8 meters per second. And so now the student can pick different things. So you can create all sorts of like different things that happen based on different values that you put in. Yeah, let me pause again real quick and just see if anybody has any questions on this so far. I've only really shown you like just scratching the surface of what this thing can do. But yeah, let me pause to see if anybody has any questions. Ernie said no questions, just an awe. Cool. All right. One other just tiny little thing is like we could instead of saying like 4, 6, and 8, I could say bike A, and if I put in 4, bike B, I could put in 6. So you could if this isn't a number, I should change this to bike then as well. If it's not just a number, but you want it to kind of feed a number into the extra math, you can put a bracket with a number behind it. So we have some questions like a free fall question where students selecting whether to drop a hammer or a paper ball or something like that. So again, this it can look, yeah, it's there's a little bit more like programming looking stuff in this, but keep in mind, this was like, we made this with just like 7 lines of code. So there's a little bit of a learning curve, but definitely like click on the dynamic simulation. Let me actually, I'll open this one. And this one, like you don't have to start from scratch. And we'll add some more samples. Yeah, you don't have to start from scratch. You can look at the thing that we already created and you can play around with what we have here and just see how kind of things change each other. But yeah, and then lastly, if just to show you that if you want to get like really fancy, we just added, oh, I don't think this is it. Abby, I hope we saved this. Okay, here we go. So this one, it has some conditional statements in it, and there's descriptions and the directions about how to do conditional statements. But we essentially just decided we wanted to make the balloon rotate and grow, and at 3 seconds, the balloon would pop. So you can do all sorts of stuff, and when you start getting into conditional statements, it's even more powerful. All right. A couple questions. Ernie said agreed, but also could you show something kinematics and calculus related? I'm not 100% sure what you're asking there. Ernie, do you mind unmuting yourself and just asking if you're comfortable doing that, or feel free to just clarify typing it in.
Yeah, no problem. I'm just wondering if um so you added the application of some calculus-based questions in the past year. Wondering if we can how that gets incorporated into a problem like this that you create.
Yeah, got it. Did you mean with with a simulation or just with like kind of a more normal static problem?
Um, I guess start from the static and work
Okay.
your way up, maybe.
Sure. And then real quick, also, Seth had a question. He said, with a subscription, can we add new questions to your pre-made courses? Yes, but in a slightly different way. So let me answer Seth's question first, and then Ernie, I'll switch over to hopefully showing you what you were looking for on the calculus side. So Seth, let me see. If you go to create, so our courses are are locked in, and so you can't technically like modify our courses, but what you can do is you can go, sorry, advanced, create courses, units, and skills. And then I have like Jack's course here, and then you can take our units. So we could go physics, unit 1, and you can just clone our course into your course, and then you have complete control over it. So technically, no, you can't modify our course, but you can clone our course, make it yours, and then you can change whatever you want. Seth, will you let me know if that made sense?
Yep, that makes sense. Thanks.
Cool. All right. Olivia said, I missed the beginning of the webinar. Where do we access the directions? Okay, so a couple things. There's a general directions right here. There's also a webinar in I'm going to do another one of these in 30 minutes that just goes over like the basics of this. And then also on the question creation itself, there's a green button in the top right, and these are questions or these are directions just for creating your own questions. I didn't want to combine those with the regular teacher directions because that would get way too long. Okay, back to calculus stuff. Yeah, so I think probably the most useful things that we've added for calculus, and sorry, let me close some tabs so I don't have too much going on. All right. So some things that we've added that would make it a lot easier for you to create calculus questions is if you are familiar with, I think it's pronounced LaTeX. First, you can put in integrals like this. Let me see if this copy and paste works. Okay. Yeah, forgive this in a box right there. But you'll also notice that within the LaTeX, you can put a randomized value. So let's say I said m equals a random value from 10 to 22 sig figs. So we can put in randomize. Essentially, we can randomize anything within within things here. I could also say, so this is a definite integral. Let me make it, okay, let me make it an indefinite integral. And then I could say, okay, or let me make, I'll do a derivative. So I just say, so I can remember it. So I said, what is the derivative of, and let's put in a variable, we'll just call it C X, and then I'm going to go superscript. Oh yeah, in my superscript, Abby, real quick, can we put a variable inside a superscript?
Yes.
Okay, cool. And let's make that P. So I'm going to say P equals rand of 3, 5, comma, let's go 1 sig fig there. So, oh, and let me set this back to the default rounding. So what is the derivative of 11x to the 5th? So now it's randomized right here. And then if we wanted to, we can put in a symbolic answer. And if I remember my math correctly, it would be P times C. And I think those need variables. Or actually, let me just go. I believe I need the variable tag in there, but let me double check to the. I think this is right.
I think you want to do A equals in your
Oh
extra
yeah. And actually, let me just get rid of that. Yeah, this would be the simplest way to do it. All right, there we go. So then again, this will be randomized for different students. So this would be a calculus application of it. By the way, on this one, so that's a student can kind of put in whatever they wanted to. So they could say 16 times 3 times x times x, and I believe that'll still be marked right because so we're not picky about having it be in the exact same format. Yeah, so on the calculus side, that is okay, cool. I got a thumbs up from Ernie. Yeah. Yeah, and let me pause there again and see if before we wrap this up, any other questions about question creation, simulation creation, or organizing your own courses? Cool. Well, if you do create something, please, Abby and I are having a ton of fun, like creating our own simulations. Always have fun creating our own problems. We would love to see what you guys create. So please definitely share it with us. I'll email you a recording of this webinar, probably tomorrow morning. And yeah, thank you so much for coming. Really appreciate it. If you have questions anytime later, my email address is all over the website. It's on the dashboard. It's on the homepage. I'm always happy to help. Always try to respond to you really, really quickly. I get a little overwhelmed at the start of the school year, but usually just back to you in a few hours, but definitely within 24 hours. But yeah, Abby, thanks for helping out, catching all my little mistakes, and thank you everyone for showing up. Really appreciate it, and always here to help if you need anything.